Today we're going to talk about scientific notation, and scientific notation is going to be useful in math class as well as science class. So to begin, before we get into the actual scientific notation, we're going to talk about multiplying by powers of 10. So if I look at this, I have 10 times 0.5. And when I multiply by 10 or 100 or 1,000 or so on, I simply count how many zeros there are, and that tells me how many places to move the decimal. So if I'm going to multiply by 10, it has 1 0, so I'm going to take this decimal and I'm going to slide it to the right one place. So 0.5 would then become 5. If I multiply by 100, it has 2 zeros, so whatever number I'm multiplying by, I'm going to take that decimal and slide it 2 places. And in this case, I would end up with 5 as well. And then if I'm multiplying by 1,000, 1,000 has 3 zeros, so I'm going to slide that decimal 3 places, and this one would be 5, 2. Example 1 wants us to figure out what we're going to multiply by here. So we are starting with 46 hundredths and we're going to end with 46. So what am I multiplying by? Well, we know that it's got to start with a 1. We just need to figure out how many zeros it has. So if I look at the 46 hundredths and I want the decimal to be at the very end, so I have 46, that's going to be 2 movements of that decimal. So that means I need 2 zeros in my answer. And then for part B, I'm going to multiply something by 0.6562 and end up with 656.2. So if I look at how many spots that would be moved, 1, 2, 3 spots. So I always need that 1, and I need 3 zeros to get that decimal moved over. Example 2, we're gonna look at a million in both parts of this. The first one wants us to write it as a product of tens, and the second one wants us to write it as a power of tens. So a product of tens is simply multiplying a bunch of tens together. And for part B, the power of 10 is writing it with 10 to an exponent. So if I think about a million, I got to get to a million. So I'm going to multiply 10 times 10. That would be 100. 100 times another 10 would give me 1,000. 1,000 times 10 would give me 10,000. 10,000 times 10 would give me 100,000. And 100,000 times 10 would give me a million. So if I count 1, 2, 3, 4, 5, 6 zeros, and I come back and look at a million, 1 million has 6 zeros as well. So that's a product of tens, a bunch of tens multiplied together. Now to write it as a power of 10, we are going to have 10, and then we got to figure out how many tens do we multiply together. Well, if we count all those, there's 6 of them. So that means our exponent is going to be a 6. So 10 times 10 times 10 times 10 times 10 times 10 is the same thing as 10 to the 6th power. Much simpler written with the exponent. All right, scientific notation is a way of writing large or very small numbers. So important part here, you need to make sure that the number in the front that you're multiplying by is greater than or equal to 1, but less than 10. That's the rule for scientific notation. If that's not true about that number, then that number is not written in scientific notation. And then we're going to take that number and we're going to multiply it by 10 to an exponent. And that's what scientific notation would look like. So here, this problem is written in scientific notation and we need to write it in standard form. So 6.85 times 10 to the 8th, I'm going to take that 6.85, and 8, the exponent tells us how many spots we're going to move that decimal. So we have to move it 8. And it's positive 8, so we're going to move it to the right. 1, 2, 3, 4, 5, 6, 7, 8. And then we fill in those empty spots with 0. So if I rewrite that, I have 5 zeros. And then we can add our commas in there. So 68,500,000 would be our answer for that in standard form. So standard form is just regular, write it as a regular number. Now this one, we're starting with 1.67. and we look at our exponent, it's -3. So that's going to tell us we have to move that decimal 3 to the left. So 1, 2, 3, and that's where our decimal is going to go. We're going to fill in those empty spots with zeros. Now we always have to have a 1 spot, so we're going to put 0 point and then our 2 zeros, 1, 6, 7 for that to make it the correct form. So notice if you're given scientific notation and the exponent's positive, you're going to have a whole number answer. If you're given scientific notation and the exponent's negative, you're going to have something less than 1 as your final answer. All right, so this one gives us a number and asks us to write it in scientific notation. So we're going to take that number. We're going to figure out where can I put the decimal to make a number between 1 and 10. So a good spot here would be between the 6 and the 5. So I have 6.5 because that's definitely between 1 and 10. We're always going to have times 10. And then we got to figure out how many spots did I move that? 1, 2, 3, 4, 5, 6 spots. But because we started with a number that's less than 1, our exponent is negative. Because if I took that 6.5, that -6 number tells us we have to move left 6 to get our starting number. So be careful on the negative numbers. Even though we counted our decimal over to the right, our exponent is still negative in this case. And then part B, to make a number between 1 and 10, we have to write this in scientific notation. I'm going to put the decimal between the 6 and the 7. So 6.72. We don't have to write all those zeros at the end because that's all that's left. And then we have to have a times 10. And in a whole number, the decimal is always at the end. So if we count, that's 1, 2, 3, 4, 5, 6, 7 spots. And even though we move to the left, that's a whole number. So our exponent needs to be a positive number. So that is scientific notation. That's going from standard form to scientific notation. And then back up here, we were given scientific notation and we put it in standard form.